Right. Good morning. Week 1, Friday. Today's lecture, where we will go from 8:30 to 9:20, and then 10:30 to 11:20. So it's 2 hours of lecture. Okay. So the agenda for today is we are going to complete the introduction example, which we are almost done, and then we are going to look into unsymmetrical bending. Okay. So I'm going to help you recall your symmetrical and what do you mean by unsymmetrical bending. So on our last lecture on Wednesday, we left off in we were doing failure analysis, and I show you different sets of formula they were used for axial loading. Okay, you can see this was for axial loading. Okay, by the way, this is Wednesday's notes. Okay, and then I show you formulas and stress distribution for uh, uh, shear stress due to torsion, and then the shear stress due to shear force. Okay. So after our analysis, okay, we go into this table. Okay. We locate elements at 4 different positions. Element A, element B. Okay. So element A positions here, B, C, and D. And then we also define what stresses do they carry. Okay. So for axial load, all elements carry a load of px over a. Now the next thing interesting is the bending moment. Okay, due to the bending moment, right? The maximum or the tension is in point A, or the maximum tension, and the maximum compression is at point C. Point B and point D are 0 because it's at its neutral axis. Okay. Based on the torque, all of them are carrying a torque of TR over J. And based on the shear force, okay, based on the shear force, all of them are again, you have a similar trend in the sense that you have your shear force highest at point B and point D, okay, or shear stress, the shearing stress induced by the shear force, okay, whereas A and B, you have 0 shearing stress. Okay, so now we have to pick, I repeat again, we have to pick which elements will see the highest stress. Okay, which element, I repeat again, which element will get to see the highest stress. Okay, so we're going to pick if we were to pick based on normal stress. Okay, we will pick based on normal stress. Okay, so based on normal stress, right, point C will be the highest. Okay, higher normal stress. In compression. Okay, yes, the highest or it's bad to use highest. We're engineers. Okay, maximum compression. Okay, I'm going to put negative. Maximum compressive stress. So point C is the location, okay, of maximum failure based on normal stress. Okay, now if it's based on shearing stress, okay, that might not be true, right? If it's based on shearing stress, that might not be true, which I'll do later when we go into week 8 and week 9, which one to choose. Okay, but for now, I'm going to show you an example. I'm just going to show you at one location, which is point C. So you realize that point C is the position that failure will initiate and failure will occur. Okay, so no point calculating point A, or no point analyze or calculating the stresses at point A, point B, and point D to select your material. We're going to zoom in into point C. Okay, so now next, what we're going to draw is I'm going to again copy this diagram over here, or you know what? I'll get the whole thing over there. I'm going to paste over here so that you can see better. The picture did not come. Cheeky sort. I'm going to get a picture over. I do apologize. Yeah. Okay. Okay, this is good enough. Okay. So now we are going to draw the stress state, or we're going to construct. Okay, we're going to draw. Okay, we're going to draw the stress state at element C. Okay, we're going to draw element C. So element C is down here. We're going to draw the stress state of element C. Okay, so we start construct. So we follow our transformation. So this is our Y, X, and this direction is our Z. Okay, so we are going to draw our element. So element C looks like this. It's at the bottom of the shaft, as you can see. Okay, that is our element C. Okay, so this is our element C. Then we realize that element C, you have this direction over here. So this is your stress X, right? Why I drew stress X in compression? Because from our analysis, we realize that stress X is in what? Compression. Okay, both of them are minus. We did not select stress at, sorry. I have to calm down first. We did not choose element A is because the axial load is generating compression. The bending moment is doing a what? A tension. So it will not have a highest magnitude. Okay, so that's why we pick C. Then we have shearing stress. Okay, so if you look on how the element is twisted, okay, so this is due to the torque. Okay, that is pretty bad. I should not have. So that is due to the torque, right? So the torque will induce a shear stress this way. Yeah. And torsion, later on I'll teach you, that will be its reaction. Okay. Then if you so we only have these stresses. So what do we call the shear stress I've just drawn? Okay. So this is shearing stress. The intersecting plane is on the x-axis. The shear stress is in the z-axis or z direction. Okay. And then shear zx. Okay. I will again teach you guys labeling all this when we reach to that chapter. Okay. So from here, what do we know? Okay, what do we know? Okay, we know this. We know that stress X is compression. We also know that stress Y is equal to 0, no stresses at all, right? We know that stress Z is also equal to 0, okay? And we know that shear XZ is equal to shear ZX, okay? Then from here, right? Now you'll see where the commonality comes in, okay? If we go back to week number 1, okay, what is the common with this element and what is the common with the element that we acquire from material properties, okay? So if we look at week number 1, is it week number 1? Yeah, right? When they construct or when they get this table, they also got it from what? An element. You can see how they construct their element and then how they construct Mohr circle. We are going to do the same, right? We are now going to we broke down the loading into stresses. We now construct the element, and then from the element we are going to draw what? Mohr circle. Okay, so now I'm going to sketch Mohr circle. Okay, we are going just a sketch. Okay, now for this case we realize that this is not a 2D problem. This is a 3D problem. Okay, so I'm going to briefly do a 3D Mohr circle for you guys. Okay, so I'm going to draw into a graph. So I'm going to orientate my my elements in such a stage that you could recognize it. So now I'm going to call this my X. Okay, and then I'm going to call this my Z. Okay, and then whoa, this is very early for this, and this is my Y, right? Based on the rotation. Okay, so now I'm going to draw our element. Then we're going to sketch out our element. Yeah, I'm going to make it a cube now. Okay, so we know that it's going on compression, right? It's going on compression, and then it's doing this. Okay, so this is our stress X. This is our shear XZ, and this is our shear ZX. Okay, so now we are going to label this is our X, this is our Z, and this is our Y. Okay, so now we are going to construct a 3D Mohr circle. Okay, we're going to construct a Mohr circle. So on a Mohr circle, those of you that have taken 3C, you will remember. If not, don't worry. Okay, some students told me that they have not taken 3C. It's okay. I'll teach again Mohr circle. Okay, so on Mohr circle, the x-axis is normal stress, right? On the y-axis is shearing stress. Okay, and this we have element rotate clockwise, element rotate anti-clockwise. Okay, so we have stress x is in compression. Okay, so we have stress x in compression. So I will draw stress x arbitrarily somewhere around here. So 2, 4. Okay. Right. So this is where our stress x line. Right. And then we have our stress y and stress z have 0 stress. Okay. So this is 0. Then we have our shear. Okay. So I'm going to put our shearing stress at a value somewhere around here. Okay, so that's our shearing stress. And then our shear is based on rotation of the element. Okay, do not worry if you don't get this yet. It's fine. Later on, I'll teach more into detail. This is just an example for you all to see. Okay, so we put it on the center. Okay, put our finger at the center. If we look at point X, okay, those of you that have done 3C, maybe you can remember. I'm just probably recalling, okay, to help you recall. So at point X, based on this shear stress, the element is going in a clockwise direction rotation.